Alright, so let's look at my Think Aloud. It's asking you to do the exact same thing that we did in our last problem, to expand and simplify the expression below. So this is my expression. The very first thing I want to do is to make sure each of my variables have a coefficient. I see an x, it does not have a coefficient, but I know it has a coefficient of 1. This y does not have a coefficient. By default, it always has a coefficient of 1. There's my constant. This variable already has a coefficient, and there's my other constant. Another thing that I notice about this problem is I have this set of parentheses being multiplied by this set of parentheses. We are still going to be using that distribution property. However, since I'm multiplying with a 2 terms and with a 3 term over here, that means I'm going to be showing you how to do it using our tabular method. And the tabular method is something that you might have seen in the past. It is also called like the area model, but now that we're in algebra, it's called a tabular method. The very first thing you start out is with a square or a rectangle, and I'm going to be breaking up this rectangle based on how many terms are in the parentheses. So on the top, I'm going to be breaking it up by the first set of parentheses I see. I have 1, 2, 3 terms. That means I'm going to be breaking it vertically to 3 equal spaces. So I have 1, 2, 3. After that, I want to grab each of those terms and place them on the top. So my very first term is 1x. My second term is a positive 1y. Make sure you are taking that operator in front. Then I have a positive 6. So I just did my first parentheses. I'm now going to focus on my second set of parentheses. How many terms do I have? I have 2 terms. I'm going to be writing those terms on this side, but first I need to split this to have 2 terms, or 2 spaces. So I'm going to cut it in half, and now I'm ready to write those terms on the side. First comes 2x, and then comes positive 4. Make sure you are taking the operator. It is going to make the difference. Now, I am now set to use my tabular method. In order for me to do this, I'm going to be finding the area of each square. To find the area, so let's say we're talking about this square right here, that means I'm going to go all the way up to the outside, and I see it's 1x. And then I'm going to go to the side, it's 2x, and I'm going to be multiplying those together. The best way to multiply is to first multiply the coefficients. So I have 2 times 1. 2 times 1 is 2. Then I have the base of x. So x times x. That is where our product rule comes in handy. So I know my base is x. How many x's do I see? 2, so that's the exponent. So 2x squared. That is how I found out the area for this square right here. Now let's look at this one. So to find the area, I see 1y being multiplied by 2x. The very first things I want to multiply are the coefficients. So 2 times 1. 2 times 1 is 2. And then I'm going to look at the variables. X times y. They are not the same base, so I'm going to be putting them side by side. X, y. There's one thing I did miss. What type of 2 is this? Is this a positive 2 or a negative 2? It is a positive 2 because positive 1 times positive 2 gives me a positive 2 back. Now to find the area of this one, I'm going to go all the way up, 6. Then I'm going to go all the way to the side, 6 times 2x. So 2 times 6 gives me a positive 12. And I have x right here. I don't have an x over here. That means my x is just going to follow. So I have a positive 12x. Now let's look at this one. This square is going to go all the way up. So it's 1x. Then it's going to go to the side times 4. So 4 times 1 gives us 4 back. I see my variables. I only have 1x. So I'm going to just bring it down as 1x. Now to find this one, I'm going to go all the way up, and I have 1y being multiplied by 4. So 4 times 1 gives me a positive 4 back. And then I see the variable y, so I'm going to drop it down because I don't need to multiply by anything. In this very last box, I'm going to be 6 times 4, which is a positive 24. So at this moment, you have all of these terms inside the tabular method. You want to bring them out. And what I mean by bringing them out is that I want you to write them the way you see it. So I have 2x squared plus 2xy plus 12x plus 4x plus 4y plus 24. So I now have this, and I'm ready to start finding my like terms. So the very first thing I notice, I have x squared. I'm going to be looking if I have any more x squares. If not, I'm going to leave it alone. I don't see anything x squared anymore, so I'm going to leave it alone. Do little check marks, I know, just to leave it alone. Now I have 2xy, so I'm going to be finding if there's anything else with xy in them. Nope, it's going to stay the same. Now I have 12x. Do I have any more that have x? Well, I see 4x. So I know these are like terms. I'm making sure I'm taking the operator in front. So those are like terms. Now I'm looking for 4y. Do I have anything else that just has the y in it? Nope. So that's going to stay the same. And then I have my constant of 24. Do I have any more constants? Nope. That is going to stay the same. So the only thing I'm going to be combining is positive 12x plus positive 4x. If I were to combine them, I know it's going to be a positive 16x. Everything else, I put little check marks so I know I don't need to combine them with anything else. So I'm going to drop what I see. 2xy and then 2x squared, a positive 4y, and a positive 24. This is my answer.